Welcome to my presentation. My name is Caleb. At the MagLab, we're interested in creating materials with special magnetic properties. But predicting what materials would be good for this is not at all straightforward. One method that we've been using to look for these is to tune an established structure by swapping out the ingredients. This will change the lattice spacing without changing the shape, which can result in slightly different properties. In the case of the europium 122, we see a gap right here in the europium iron germanium 122. If we could form this europium iron germanium, it would be right on the border between magnetic and non-magnetic, which could result in some cool properties. My project this summer was basically just to try to produce this never-before-seen 122. To make my crystals, I tried 10 different growths based on several 122 recipes that worked in the past. Some of these were attempts at a europium iron germanium 122, but some were just controls to verify that the method worked. In each one, I used a flux growth, which consisted of putting my ingredients in a crucible with a metal solvent, heating it up to about 1200 degrees Celsius, and then cooling it down slowly and centrifuging out the flux. This is a lot like growing sugar crystals in water, where you dissolve something in a liquid to help form big crystals. The only difference is this is high temperature metals. Once I had crystals, I had to identify them, and this was done using PXRD and EDS. PXRD, or powder X-ray diffraction, uses Bragg's law to determine the crystal lattice structure of the material. EDS, or energy dispersive spectroscopy, measures the emitted X-rays and tells me the chemical composition of the crystals. Together, these can be used to compare my crystals to each other and to past works. Then, if any of my crystals showed promise, I could measure their magnetic properties using an MPMS. Out of all 10 growths, no 122s were formed, unfortunately. However, what did form is these 4 structures, which I call the geode, the claw, the bar, and the pillar. The first 2 don't show up in our crystal database, which means that they are relatively unexplored. Furthermore, they have the same composition, which illustrates that they may be showing a phase change as the claw grows out of the geode. As for the other 2, the bars indicate a higher germanium percentage than recorded possible, and the pillars are suspected to be a 166, which has many applications in condensed matter physics. In conclusion, though I didn't get any 122s, I made a lot of progress narrowing down growth methods. Based on my research, I think that the next steps would be to grow these 122s in a high temperature facility, or perhaps in a high magnetic field environment. Either one of these methods could produce the necessary ordering energy, which seems to be lacking in these stubborn 122 crystals. That's all for my presentation. I'd like to thank my lab for being so supportive to me in this entire summer. I've really felt accepted.